Hi, my name is Leanne Hill and I'm an A+ science trainer, and today I'm really excited to talk to you guys about bean bunny evolution. Your students will love this activity. It's highly engaging and it's a great demonstration of evolution through natural selection. By definition, evolution simply means change over time, and that is being demonstrated in this activity through gene frequency. For this activity, the materials that you are going to need. You're going to need a bag of red beans and white beans. You can just get those from your local grocery store, very cheap. Or if you already have something in your room that would work, so maybe you have some different colored beads, as long as they're the same basic size and shape, those will also work, okay? You will also need a container for students to sample from their population. The materials list calls for, small brown paper bags. I just find those tear very easily in my classroom after a couple of times that they've been used. I already have these containers, so this is what we put our beans in for sampling. You're also going to need 3 Petri dishes, and you'll be able to use the tops and the bottoms of the Petri dishes. And what you want to do with those is label those according to genotypes. We have homozygous dominant, our 2 capital F's. We have heterozygous, capital F, lowercase f. And then we have homozygous recessive, our 2 lowercase f's. So in this demonstration, the red beans are dominant and the white beans are recessive. The red beans are going to represent those alleles for fur, and the white beans represent the ones that are furless. As you are doing this activity, make sure that you have students stop after they have completed the first generation of bunnies. Now obviously, there's a couple of liberties here that we're taking. We're assuming that the bunnies just reproduce once, not several times. So there is a little bit that we're controlling that maybe isn't a perfect example in nature, but this is a great example that students will see how the recessive alleles, when those bunnies die, that they will not be reintroduced into the population because they have failed to reproduce, obviously. So you guys wouldn't have to sit here and watch me by myself sort the bunnies. I went ahead and did the first round, and these I really did. It took me a few minutes. Typically, students working together, you might have the first student do the first generation and then swap, and the other student, while you have a person recording the data. So if you look at your data chart, which is provided for you in the module, when you look at the first 3 columns there, it is strictly asking for the number of bunnies. So the first column, the number of homozygous dominant bunnies, then heterozygous, and then homozygous recessive. So make sure students are counting the pair of beans for each one of those, because they can kind of get their numbers off if they don't. So in this first generation that I drew, I have 14 homozygous dominant bunnies, I have 22 heterozygous bunnies, and 14 homozygous recessive bunnies. Now, the next thing that you have to do is you have to record the number of dominant and recessive alleles. So you want to make sure your students understand the difference in what they're recording. Bunnies in the first 3 columns, the number of alleles in the next 2 columns. And these are going to be the number of alleles that survive and will go on to reproduce again. So the first time, well, you'll do this every time, but your homozygous recessive bunnies exhibit the phenotype where they are furless. So based on the environment where they are living, they are going to die. So I like to give my students a Ziploc bag to put their dead bunnies in, okay? So put that over to the side, okay? And then they will put the surviving alleles back in there, okay? Now, the number of dominant alleles for this first one should be 50. It should be with what you started, because your dominant alleles are always going to continue through the population. The number of recessive alleles. So these are the ones that survive. So the only ones that are surviving are those that were heterozygous. So if the number of heterozygous bunnies is 22, that also means my number of recessive alleles is 22 as well. So that gives me a total number of alleles being 72. Now, you can have your students calculate gene frequency now. I have seen this done where teachers will wait till all the data has been collected and then go back and calculate the gene frequency. I prefer calculating the gene frequency now, because this is also a way to easily check and verify your students are doing the calculations correctly. So the way that you do gene frequency is you take the number of alleles and divide it by the total. So the gene frequency for your dominant alleles is 50 divided by 72 in this first example. And you want your students to write this in decimal form. So in my example, I have 0.69 for gene frequency of my dominant alleles. Then the recessive alleles. I have 22 recessive alleles divided by my total number of alleles, 72. So that gives me a gene frequency of 0.31. So when you're walking around and checking students with this activity, make sure you catch a glimpse of those two gene frequencies and tell students if they are calculating their gene frequencies correctly, the two together should add up to equal 1. So that's a good way to easily check. And at this point, I recommend you stop, make sure everybody is good, that they've got that first round good. You know, you're walking around informatively assessing your students during this process. That way, if there's an issue, you can catch it round one, you know, to prevent any further problems. Then students are going to continue this same process for a total of 10 generations. And that is what teachers who are attending our virtual training are doing as well for this activity. So you will go through the next remaining 9 generations doing your bunnies, your alleles, and calculating gene frequency. Then you will calculate a graph of the allele frequency, and you'll put this both on the same graph. So I look forward to seeing your results and discussing with you any modifications or challenges or problems that you encountered along the way. I hope you guys have a really great time with this activity. I know your students will. Thanks.